From the start of Earth's existence, life evolved with chaos and disaster. Surviving deep underground to return to the oceans once again. Life endured ice, then prospered when finally oxygen became abundant. From microbes to the first complex creatures, life was always searching for new frontiers on a miracle planet. $450 million years ago, the Earth had become a less violent planet. It was no longer being bombarded by giant meteors from space. The great ice ages had passed. Nothing yet lived on the land, but in the warm and shallow seas which fringed the continents there was a rich diversity of life. Fish had not yet evolved jaws, so these Arandapsis, the distant ancestors of terrestrial life, remained close to the coast where they could feed. Segmented creatures, the trilobites had diversified into many species. Just beneath the surface, the mantle is made up from molten rock, which moves slowly with the force of gravity. The movement is both circular as well as vertical. This convection drives the restless drifting of the continents. Oceans are drained as the land masses collide. But the waters move elsewhere, and so new environments are born. Continents move very slowly, but over millions of years, the changes are dramatic. But not only were the continents being forced to change, life was also modifying its shape. An arms race had begun. In the French National Museum of Natural History, Dr. Daniel Gouget has studied this period of prehistory and the armored and predatory fish that had evolved. 410 million years ago, giant predators were hunting the oceans. These creatures had developed a new and mighty weapon, the jaw.
With the invention of the jaw, you get to a new possibility for the animal to become a predator.
They have a unique skeletal structure that does not exist in any fish today. The front part of its body was shielded in hard, armor-like bones. Instead of teeth, they had bony plates in their mouths, which acted like a pair of razor-sharp scissors. With strong jaws, the placoderms dominated the seas of the Devonian period. They were like armored sharks. Our early ancestors had no chance against predators like these.
The Ostatians were there, but they were absolutely under the dominance of these placoderms, which were adapted to all kinds of environment. They represent about 75 to 80% of the vertebrates you find in the Devonian. So our Ostatian ancestors were certainly in the shadow of the placoderms because they couldn't develop.
Over millions of years, the jawless fish Arandaspis had become extinct. But one of the fish that had evolved was this, called Eusthenopteron. Science knows it as one of the lobed-finned fishes. And this one was the stepping stone to the creatures which would eventually come to walk on land. It was a good swimmer, but could not compete with the placoderms, so it had to seek alternatives. Life was now becoming a series of strategies, both for predator and prey. Strategies that were sometimes dictated by the earth itself. The clues are in the rocks and the history of the continents as they shift. The fossil record now is widely scattered, but when we move back in time, the sites move together to where the creatures once lived. The interior of this continent was empty, a dry desert with no life. When the continents clashed, the force threw up a great mountain range. We know it as the Caledonian Mountains. The northernmost site of those ancient mountains are in Norway, here at Sognefjord. The folds and curves in the rocks can only hint at the forces which are at work in the earth. At the point of collision, solid rock can bend and twist as the massive forces at work blend one vast landmass with the next. When the ancient continents of Baltica and Laurentia met, they shaped the hard rocks as if they were putty in the hands of a potter. This sinuous rock formation is known by geologists as a fold. Here is another part of those vanished mountains at Monreath Bay in Scotland. 430 million years ago, these twisted and tortured rocks, folding over and upon each other, were also part of the shoreline of the Aaptis Sea. The southern tip of the collision is in the east of the United States. This too was once a part of the Caledonian Range. The strata folds its way for thousands of miles from the USA to Norway. But of greater interest to prehistorians is what happened when the Caledonian Mountains were forced up. When the ancient Aaptis